It's 2:30 and welcome to discussing how we can help with street and pavement management using GIS enabled tools. My name is Chuck Wright. I'm a GISP and a Microsoft certified solutions developer. Very proud and happy to serve as Innovation Services Director at Withers Ravenel Engineering. Great position that allows me to look at all kinds of innovative and fun tools and really focus in a lot on GIS with that. I want to say thank you to everyone here today. Very happy you've chosen to join us for this session, as well as thank you to the North Carolina GIS Conference for having us. So with that being said, I'm going to go ahead and dive right in. So first, hopefully a lot of this doesn't need to be said, but we're going to be focusing in on pavement and our roads and street network as an asset that we have within our state. So this is a very important asset, key to economic growth, obviously bringing products to market, helping bring workers to jobs, etc. But on top of that, getting business and work done is also key to our recreational activities. I don't know how many of you, COVID time, we can't go and get in public, but you might still be able to enjoy a nice drive in the mountains or to the coast or something like that. And also, why is it so important to keep these roads well maintained? Well, obviously, safety is a major factor. So we're going to be diving into some of those tools that can help with all of this. I did want to frame how big this issue really is. So North Carolina, it's the good road state, has nearly 80,000 miles of state maintained highway. That's a really big, about $5 billion annual operating budget. As you can see, we've also, that's not just at the state level, but at the local, the county, the municipal level is also very important. I've taken a few, key or sample of different municipalities here across the state, kind of give an idea and a framework of how many miles of road that they do manage. We've got everything that may be covered up by my picture, but Charlotte, North Carolina has upwards of 2,500 centerline miles. Raleigh has about 2,300 lane miles. Notice those are different, centerline miles being, as you would think about it in GIS, the length of a segment, whereas lane miles being 2 lanes or 4 lanes, you would take that center line distance and multiply it by the number of lanes. As we get into talking about the tools a little bit, another measure to keep in mind that's really important, that's often used, is actually square yardage. So if we go to do repairs, we have to order asphalt, other items and materials. We can do that using square yardage and not simply center line or lane miles. So I've got a few main points that I want to go through and make sure that you have the opportunity to lead today as we demo some of these tools. First, for any asset management, it is important to have a framework or a mental model in place to really make sure that we're optimizing those assets and those investments. In the US, typically pavement management is a leader in this asset management practice. A couple of very key reasons for that. First of all, it is highly visible. So when you compare pavement to something like water or sewer, which is typically buried underground, pavement is something that we interact with on a daily basis. If a road's not in great shape, we know it. We're able to hit ruts, and we have road quality and ride quality, that is very apparent to us as we drive on a daily basis. And another place where pavement management typically comes to the forefront is just on the life cycle of that pavement. So as pavement goes from being brand new, freshly paved, to being at end of life, we can see that actually happen season over season, freeze-thaw cycles, other items, see that degradation in place. Whereas something like water or sewer, just to use a counter example, we put those pipes underground, we may expect them to last 50, 70 or more years, and we typically don't think about them. That goes down multiple generations. Pavement, because of those two key factors, typically has more assessment availability, more asset management programs that are in place for it. So this is a great example for us today. And then also the last one is we're going to touch on 3 separate tools, how that can help with pavement management. The first one is a pavement condition survey tool that we developed in-house at Withers Ravenel. Another one is called Capital Predictor from Dude Solutions, which is for needs forecasting. And then finally, Work Planner, also from Dude Solutions, which plugs in with Capital Predictor for actual project planning. So, I discussed as the main point of framework. Again, shout out to Dude Solutions, who initially, came up with this particular model, which is the APPM framework, which stands for Assess, Prioritize, Plan, Execute, and Maintain. Today, we're going to focus on the tools for assess, prioritize, and plan. Execute is one I think most of us probably have nailed over the years. Lots of great products, GIS enabled, CityWorks, Cartograph, Asset Essentials, just to name a few of those for actually the execution and the actual work and maintenance itself. The maintain step is really about being able to look back and do a kind of a retrospective on what works and doesn't work in this plan as we go through these different areas. So we're going to start out talking about assess. And to get into assessment, we will talk about our pavement survey tool. And I say mapping to the rescue because this is still an area where Excel and other Microsoft Office tools have play a big role for a lot of organizations. We have at Withers Ravenel have a transportation team that goes out and does actual windshield surveys. There's obviously a lot of other cool technology out there about vehicles actually have LiDAR scanners doing pavement assessments that way. But it's our belief that the state of technology today, there's certain items like raveling and other pavement issues that humans are still much better at picking up and doing that assessment. So when we have a team, a crew of 2 out there doing one of them, one person is really focused on driving. They're maintaining eyes on the road and other traffic. They're driving a vehicle. And then we have the person doing the assessment who has the technology in the vehicle, typically a laptop, that is doing the actual assessment. And where they're doing this, they had a need for accuracy. We want to get it right, but also for speed and efficiency. Again, the car keeps moving as they're doing the assessment, so they really needed tools to make it super simple and easy for them to collect that information. Another requirement, obviously, GPS is a boon for all of us, has been for many years. They wanted to make sure they could view their progress on the map via GPS. And also know what work is left to do. So as they're tracking their productivity, how many road segments, how many miles or feet of road have we done every day? And then finally, have support but for 2 different methodologies. I'm not going to deep dive into any of this. We're going to move through this pretty quickly. But there are 2 main methodologies used for rating roads in North Carolina. One is the ITRI methodology. The other is known as LTPP. And depending on who they're doing and the request, they may pick one over the other. So ultimately, we ended up developing in-house an ArcGIS desktop add-in. Why an ArcGIS desktop add-in? Well, the first thing is we don't want to reinvent the wheel. So we did a survey. We looked for other commercial tools that would fulfill the needs, and we really did not find anything out there on the market. So we knew we were going to have to take that to our innovation team and get something built. In the spirit of innovation, we wanted to go ahead and prototype something very rapidly, get something in their hands that they could start using. So we immediately jumped to technologies from Esri, such as Collector and Survey 123. But what we found with that is we were able to prototype, get it out, and it could definitely do the job. It would support things like calculations, obviously worked with the map, but the actual data collection process was a bit too slow, as it would do transitions between screens. Every millisecond there counts, again, as the vehicle is moving down the road. We also found the UI was not quite as flexible for our needs. So we did have this tested by our end users. They took it out, they tried it, but at the end they passed on that and came back and said, what else can you bring to the table? So next we said, hey, let's make this future-proof. Let's go with ArcGIS Pro. But at the time of the evaluation, there was no GPS toolbar. We didn't want to build our own because we figured one was coming at some point from Esri directly. And good call there, because not too long after mid-December of last year, with the release of Arcgis Pro 2.7, there is now a GPS toolbar to track your location, which is absolutely awesome. Example of Esri, listening to the client feedback and getting that out. So we ended up going with a desktop add-in, which has been working incredibly well for our team. Very positive feedback on everything. I want to drill into this just a little bit. I'm just doing screenshots today because of time. So this is what it looks like. They're using this, again, the passenger has a laptop in the vehicle. They have a touch screen, and this is what they see. Now, when they go out in the field, they have additional layers of information. They have aerial photography, parcels, etc. But this is how they can actually use that touch screen to very quickly and easily do the rating information. I'll kind of explode in a little bit more and show the two different methodologies. So taking just the form itself, making it a little bit easier for everybody to see here, we have the two, the ITRI and the LTPP. Now these forms themselves, notice everything's exactly the same on both forms, with the exception of this component in the middle. This piece in the middle, depending on which collection methodology they're using, which geodatabase they're connected to, it'll automatically display the right version. And especially with the ITRI methodology here, again, we're really going for productivity. We were able to eliminate every single drop-down box for that one, make it where it was literally just one touch screen. So as they go through where they have block transfer cracking, if they want to change that from medium to low, they simply tap the screen and it's low. That would automatically, or does automatically, update that PCR rating live and in real time. All the other information around that, which is common to both forms, are different data that we have the ability to collect while we're doing the collection. Not every client needs all of the data, but we do have that baked into the system. Some other neat capabilities on here. We are tracking how many miles or feet map units have been completed on any given day. How many total remaining in this particular project. So they are able to keep track of that on an ongoing basis for productivity monitoring purposes. In addition, we have baked in a QC, QA process. So not only is this used for the initial rating, but they can use the same form to do the QA, QC process. And again, it's tracking things like the date and time of both of those events. The users who entered the initial data did the QA, QC as well. And then one other thing that we're doing is when we have a prior assessment, when we have that data, we're going ahead and we're loading that into the system ahead of time. So it's less that they have to potentially change in the system. One of the things that allows us to do is highlight when those are very different from the last assessment. That's what you're seeing on the right with the yellow highlighted boxes. But the other thing we have because of that is in between assessments, there are going to be road segments that are completely repaved and resurfaced. In those cases, rather than having to reset all of the values, they can simply hit the repave button, sets everything to a nice new, perfect road, and then they can make adjustments from there. So this tool has been, like I said, very well received, is working great in the field, and I encourage anyone else who's doing similar work to look at something such as this to get into the hands of the folks that are doing any type of assessment work. Obviously, since it's baked into ArcMap, this tool can also be used back in the office as well for going through the data, monitoring, doing additional types of QA activities, etc. So a whole lot on the first tool, and I'll pause, and we're going to switch over real quick to the second two steps of this Appleton framework, which are prioritize and plan. And with that, we're going to start talking about the two other tools, Capital Predictor and Work Planner. What does Capital Predictor do? Well, ultimately, it, as the name says, allows us to look ahead and predict what is the condition of our assets, in this case, our roads, in the future. So we can look ahead, as far as 100 years, they typically we do more of a 20 to 50 year time frame. The other thing it allows us to do is work with our subject matter experts at a municipality or the ones that we have in-house and say, what are the common treatments or capital improvements that we would do for these different assets such as pavement. So, are we going to do, crack sealing? Are we going to do some other kind of coatings? Are we going to do a mill? What treatments are we doing? And what triggers would we normally use as a human expert to decide on those treatments? We build that information into various scenarios within Capital Predictor. The last major thing that this does, it also allows us to go through different budgeting scenarios. And this allows us to look at that prediction ahead, but that prediction ahead based on the available funding to do and actually perform those various treatments. And we'll show some examples of that. We can also, obviously with Capital Predictor is GIS integrated. We can directly integrate with a feature service or pull in shape files that would also support other data sources such as SQL Server, Excel, etc. Finally, and we'll look at this quickly, we can send that data back to GIS for further planning and analysis using GIS such as Arcgis Pro, as well as additional tools like Work Planner. So I mentioned the treatments and triggers. A big part of that, again, if we look at the life cycle of an asset, let's say this is a asset life cycle. It's a little long for roads, but I think it's a good chart anyway, kind of illustrate the point. We may see that it's in good shape in the beginning. It's green, low likelihood of failure, all the way down to red towards the end of its life. And every asset class is going to have a distinct curve that's associated with that. But when we do those treatments, like we just said, some sort of rehabilitation, then we are able to extend the life and the service of our assets. So this is what is actually happening within Capital Predictor using those rules and the available budget. It is really advanced. It uses a multi-generational algorithm to go through multiple scenarios to get to the optimal solution. For actually configuring the treatments and triggers, this is a great example of that here, where I can see multiple treatments are put in, such as asphalt surface seals, the joint repairs, patching, reconstruction. And then just to the right of that, we can see what are the decision states, what are where we would actually apply these. Is it a surface condition? Is it a ride quality issue? Is it an overall PCI score? What are the items that would make us select those treatments? And once we have all of this built and we run the model, I want to jump into some reports. And this one looks a little busy, but I'll go through and explain it very quickly here. I think you'll see it's got a ton of great data. So this is one client where we actually looked at their pavement and explored multiple funding scenarios. So we took their existing budget, which I'll point out here. It's in this orange yellow color, which was a $9 million capital improvement budget. Dollar capital improvement budget. And you can see by following that orange line to the right, they start out in a fairly reasonable service state between a 2 and a 3, but we can see that over time, that $9 million just isn't enough, and they're not able to keep up with the overall service state, which means your roads are steadily getting worse and worse over time. So over 50 years, they're actually seeing a overall system degradation. So this is an underfunded asset for their road network. And at the top there, the bars, you can see it's spending that $9 million every single year as they go through. Well, we said, well, what if we got more money? Okay, nothing else changes, but we've got more money. Well, here's the purple scenario. So this is $12 million a year. You can see, again, with the bar chart at the very top left, as they go through, they're spending all the money. But then when they get around year 22, 23 through year 33, 34, they've actually repaired the roads as good as they're going to get. But they seem to have a surplus of money, and they're going through kind of a dip there, which is a 10-year period where people might start to question, hey, is this an overfunded? How overfunded is it? So we actually compared and did various scenarios and landed on what we call the ideal $10.9 million scenario. And in this scenario, which is the blue, you can see the service state at the end of the day maintains almost identical to the $12 million. So we're over $1 million less money. And you also see the funding distribution there. The bars at the top are much more steadily paced throughout that 50-year time period. So this is the one the client actually selected to recommend as a future funding level. This is just another quick little graph of that $10.9 million funding level. It shows everything from the deep green, showing a new road, to the deep red, which is showing roads that are end of life, and what that looks like as it goes through time as an overall for their road network. And then one other thing I want to point out here, again, with this scenario, it's not just predicting out the future, but it's actually going through and modeling all of the individual treatments that would happen. So here on Aldrich Street, we can see in year 5, they're doing a microsurfacing. 2 years later, they're coming in, crack and joint sealing, and then they're doing another microsurfacing at year 10, which matches what their subject matter experts wanted to use for that condition and maintenance of those highways. So once we export this all to GIS, obviously we can get some nice maps of conditions over time, which are really nice. I've chosen here to actually show this in Pro. We can see time slider. This isn't conditions, but this is the actual work itself that is being done. So here we have the actual work plan that we have that's year by year, what treatments are being recommended by Capital Predictor. So we have a lot of variety here in 2022. If I move the slider forward a couple of years, now we can see there's more, but a lot of that is the first microsurfacing treatment on a lot of those surfaces. So the next thing, once I've got this back into GIS, once I know the recommended treatments, then I can move into tools like Work Planner, which let us actually develop projects and bundle needs from Predictor into multi-year projects. And the key here, I think, is across multiple asset types. So for pavement, there's nothing worse than paving a road, getting a nice new even surface, and then realizing that for whatever reason we miscommunication with another department, and there's a water sewer pipe that's under that road that needs to be replaced, and so we're digging up all that new pavement just to have to repatch it and go on, and now we've impacted the ride quality, etc. So with Work Planner, it allows us to bundle those projects where we're actually impacting multiple asset classes across our municipalities. And as part of that as well, it does allow you to track various funding methods, so general fund, enterprise funds, etc. And so you can actually budget out for these. And you can then, if anybody's used a tool like Trello or other Kanban board, you can actually have these cards that represent each project and move them back and forth year to year, budgetary impacts, etc. Awesome. So, quick summary here. First, we went over the APPM framework. It is important to have that framework, making sure we're hitting all the key areas. Most people are really strong in the execute, doing the work orders, doing the work, but there's definitely always room for improvement in every area. And today we showed some tools for the assessment, the planning, and prioritization. We also want to go back and partner with our pavement management buddies who are typically more advanced in the asset management program. And for those of you in pavement management, share the wealth. All the asset management practices you're using today work great to help out other asset classes. Tools like Capital Predictor as well as Work Planner are awesome because they do allow a more holistic view, breaking that data out of silos so you can see how those different assets will impact each other. And obviously, we reviewed the 3 GIS-enabled tools to help us throughout that process. Thank you very much. I know this was kind of a quick tour, and we will move to questions. And I'll pull up the chat and see if we've got anything in there. Okay, awesome. So we've got one in here. It says, "Dude, solutions, you can't dream of a better company name than that." That's absolutely true. Awesome. Um, and another one, which method to use? Assume LTPP versus ITRI. I would have to defer that one. Typically, my understanding of that is it is typically requested by the client which method that they are going to be utilizing. Um, and we have a question about data from pavement management being incorporated into Esri's roads and highways. Short answer is yes. So that's not something I've personally done at this point in time, but the data collection process or data import is very flexible. Capital Predictor itself actually has the ability to attach to multiple data sources. It has a field mapper where I didn't show this screen, but where you just pick a drop down of what available fields are there, and they fill out what is required within the software to do the modeling. Do we have any other questions? All right. Programming language. So the one that we created in-house in Arcgis desktop, we used C# and Visual Studio along with the ArcObjects language that's built into desktop. It seems to be really quick. And when we get into languages, I always say pick the one that your programmers are best at. It's typically the right answer to those questions. So great question there. So another question, missed the beginning, is the pavement condition assessment done in survey 123? The short answer is no. So data connectivity was an issue. The issue was not that we couldn't get the data. It was really an issue around having the speed and the transition between screens within survey 123. I think it's an awesome tool. I think it'd been perfect if we were doing like a manhole assessment where we're walking down an outfall and there's time in between assets. But while we have a team in a car riding the roads, it just wasn't quite fast enough. So what we ended up doing is building an add-in for ArcGIS desktop. All the data is local, it's lightning fast, and it's very, very resilient. So that's where we went. Also works great with a touch screen. Great questions. Any more? Got about 2 or 3 more minutes. All right, well, awesome. Thanks everybody again. I really, really appreciate it. Thank you for taking time out to join me today. And again, thank you to the conference sponsors and everyone. I hope everybody has a great afternoon.